This is part 4 of the chemical analysis topic in GCSE AQA chemistry. This is a triple only subject. You do not need to cover this if you're taking dual award sciences. So in this video, we're going to take a look at tests for positive ions. There are 2 particular tests that we're going to take a look at, and in each case you will need to remember how you carry the test out and what you would observe. So in the first instance, we're going to look at flame tests. There are 2 alternative methods here, equally valid. On the left hand side, the one that could come up, you could be expected to remember it. We take nichrome wire, put it in concentrated HCl, and then heat it to clean that wire. We can then dip it back in the acid and then dip in the solution that we are testing. Hold that into a Bunsen flame and look at the colour of the flame that's produced. A much simpler method is to soak a wooden splint in a salt of what we want to identify, so the positive ion. We then put that splint into the flame and we see what colour we get. It's really important that you remember each of the flame colours for the 5 examples that we have in this table. So see how you do, and then we're going to run through them in a second. So, lithium would be a crimson flame, whereas sodium would be a yellow flame. Potassium would give you a lilac flame. Calcium gives you an orange-red or brick-red flame, and copper ions will give you a green flame. So remember, you have to know how you carry the test out, and you need to remember the specific colours for the specific metal ions that have been provided. Why might there be a problem if we have got, it might be sodium ions, it might be calcium ions? Why might the flame test not help us to identify? Certainly if there's a mixture. Well, let's take a look. We have got here sodium with a yellow flame and calcium with an orange-red flame. Now, if you mix yellow and orange-red together, you're going to get a vaguely orange colour. And if you have got a vaguely orange colour, you aren't necessarily going to see the yellow from the sodium. You won't know that both of them are there. Okay, now let's take a look at the second test for metal cations, that's positive ions. This one is carried out by adding sodium hydroxide. And you will need to remember the observations for all 6 of the positive ions listed at the top. The way we do it, we take a centimetre depth solution of what we're testing, so an aluminium salt, calcium salt, magnesium salt, copper salt, iron 2 salt, or an iron 3 salt. We then add 5 drops of sodium hydroxide, note our observations, but then you can also continue to add an excess of sodium hydroxide to see if there is any change. Really important, a precipitate is an insoluble solid which is formed by a reaction taking place in a solution. So when a solid precipitates out, it's where 2 solutions have mixed to form a solid, mixed and reacted to form a solid. So think about what's going to go in to this table. Can you remember the facts? These are what you need to know. So aluminium ions, we would get a white precipitate, as we would with calcium 2 ions, as we would with magnesium 2 ions. Copper ions would give us a light blue precipitate. Iron 2 ions would give us a light green precipitate, and iron 3 ions would give us a red-brown precipitate. Now what we've got straight away are 3 tests that clearly identify the substance that we're interested in. If we get to a light blue or a light green or a red-brown precipitate on the addition of sodium hydroxide, we have proven the presence of copper 2, iron 2 or iron 3 respectively. Now we can't necessarily separate out aluminium, calcium or magnesium ions. But if we add an excess, what we see is that the precipitate redissolves with aluminium. But if we look at calcium and magnesium, there's no visible change. The white precipitate remains. That means we've identified a test that allows us to find aluminium ions that's unique to aluminium ions. And that leaves us with these last 2. So how could we go on to identify? We've got a white precipitate. It hasn't dissolved. So we know it's calcium or magnesium. But what we can do is go back to the flame test. Calcium will give a red-orange flame. And magnesium isn't one that we learn. We actually don't get a flame colour. That takes us to the end of this video. Thank you for listening and goodbye.